So this problem asks us to find the indicated currents, and we're going to solve it using a mesh current method. So the way to approach this is to label each of the meshes. So I will label them as I1, I2, and I3. And in particular, if you look carefully here, case of I3, you can see there's a current source. And so because of the current source, the value of I3 is known. Right, you can just read it off. Because of the current source, we clearly have that I3 is just a negative 3 amps because the arrow points in the opposite direction makes it negative. So let's write down what are the other currents, the ones that we're trying to find. So IA is going to be just I1. There's only one mesh that touches the resistor there where IA is labeled. For the case of IB, there are two meshes that will contribute, and so we'll get I1 minus I2. And for IC, again, there are two meshes that touch, so they are I2 and I3. And we assign positive and negative signs because of the directions of the arrows. Our next step is to apply Kirchhoff's voltage law at each of the meshes. So let's do it at mesh number 1. So KVL at mesh 1, we choose a starting point. Let's go here and proceed in a clockwise direction around this loop. So we will get minus 50 from the source. We will get plus 5 times the current through the resistor, which is I1. Then we approach the 10 ohm resistor, and through the 10 ohm resistor there are two currents. So the two currents will be I1 in the direction of travel, and then I2 in the other direction. So minus sign I2, and that completes our loop, and we're back to 0. So I'll simplify this equation a little bit. So I will have 15 I1 minus 10 I2 is equal to 50. And that I'm going to call equation number 1. Our next step will be to do Kirchhoff's voltage law at mesh number 2. And so for mesh number 2, we choose a starting point. So I might as well pick the node here. And again, we proceed in a clockwise direction. So I will have 10 ohms multiplied by the currents that pass through. So traveling now in a clockwise direction, I will have positive I2 and negative I1 that pass through that resistor. Then there's only one more component, which is the 40 ohm resistor. So we have 40, the currents through this one will be I2 and negative I3. And then we're back to our starting point, so that's equal to 0. And so now we can simplify this equation just a little bit. So I will bring I2 to the front, so that's minus 10, sorry, I'll bring I1 to the front, just put them in order. So that's I1 first, then I2 will give me 50 I2, and then value of I3 I actually already know, that's been calculated here. So I can substitute in that I will have minus 40 times minus 3 for I3, and all of that is equal to 0. So simplifying a little bit more, minus 10 I1 plus 50 I2 is equal to, so that would be a positive 120, but I bring it over to the other side and it becomes negative 120. And so that will be my second equation. So I will write this as an augmented matrix so that I can solve it using Gaussian elimination. So as an augmented matrix, I read off my coefficients, which are 15 minus 10 and 50. This is coming from equation number 1. And then from equation number 2, I will get a minus 10, a 50, and a minus 120. So these numbers are fairly large. I would like to rescale them. So looking at the first row there, if I actually do row 1 divided by 3, then that's going to reduce those numbers. So 15 divided 3 is going to give me 5. the 10... actually, no, I should divide by 5. What am I thinking? I should divide by 5. So 15 divided by 5 is going to give me 3. 10 divided by 5 is going to give me -2. And 50 divided by 5 is going to give me 10. And then for row 2, I should divide by 10. So that would give me -1, 5, and -12. So that's a little bit nicer. Now what I would like to do is try and get a 0 in this lower left position. So I need to find what's a combination of these rows that will achieve that. So first of all, I'll copy row 1 as is. So that's a 3, a -2, and a 10. And then for row 2, what's the combination that will give me what I want? Well, if I do row 1 plus 3 times row 2, then I'm looking at the 3 and the -1 here, and I'm thinking if I turn the -1 into a -3 by multiplying by 3, then I'll get +3 and -3, which will cancel to give me 0. So let's go ahead and calculate that. So just so that I don't make a mistake, what I'm going to do is write out just sort of over the right-hand side here the expression that I'm evaluating. So I have for row 1, I have a 3, a -2, and a 10. And then 3 times row 2, so I'm reading these numbers here and I'm just multiplying them by 3. That will give me -3, 15, and a -36. And now I'll just add these up and I get 0, I get 13, and I get -26. So now I'll copy those numbers out. So that was a 0, a 13, and a -26. Okay, I will leave the first row the same again. So I will just copy that down, and I would like to get a 1 in the diagonal. So I'm going to do row 2 divided by 13. So 0 divided 13 gives me 0, 13 divided 13 gives me 1, -26 divided by 13 is going to give me -2. So here I actually can read off the answer for current I2, my second variable. Answer will be -2 amps. But let's proceed and solve for I1. So in order to do that, what I need to do is get a 0 here in this kind of upper triangular position, or this sort of off diagonal position. So what is the update step that will achieve that? Well, I can use the 1 underneath to cancel with the -2. So if I did something like R1 plus 2 times R2, then I'm going to get a plus and -2, which will cancel. So let's go ahead and write down the numbers that I'm actually calculating. So row 1 was 3, -2, and 10. Row 2, so 2 times row 2 is going to be 0, 2, and -4. Then adding these up will give me 3, 0, and 6. So I'll copy those numbers, 3, 0, 6, and the bottom row can stay as it is because that one's fully solved. And then my final step, I need to get a 1 in the diagonal. So to get a 1 in the diagonal, divide by 3. So row 1 divided by 3. So that gives me 3 divided 3 is 1, 0 divided 3 is 0, 6 divided 3 is 2. Bottom row stays the same. And so now I can read off here, therefore, I have fully solved my system. Therefore, I1, my first variable, is 2 amps. And I2, my second variable, is -2 amps. So then what I need to do to finish this question, I need to go back and express this in terms of the variables IA, IB, and IC. So given what I know about I1 and I2, it's just a matter of substituting that in. I'll leave that as an exercise for you to do. But the key takeaway from this video is that you can recognize in some circumstances that your mesh currents are actually specified already by current sources that you have in your circuit. So if you have a current source on one of your meshes, then it will specify the value, and so you can just write it down without any further need for calculations.